Hello and good morning or afternoon, Dr. Ajib. My name is Abyaz Attaqee S.O, and I'm here representing my Group 1, for the opening of our video presentation, which is titled Random Variable Estimation Given an Event. So our Group 1, consists of 4 people, including myself. And the other members are Kalyana Pendit, Muhammad Narendra Hermawan, and Fergie Atthariq F.A. So let's go straight into the video presentation. Random variable estimation given an event. So this presentation of ours consists of 4 parts: definition, formula, application, and example. I'm only going to be explaining about the definition part. Definition. What is a random variable? It is a variable whose value is unknown, or a function that assigns values to each of an experiment's outcomes. Random variable estimation is the estimation of said random variable. There are a couple of types of estimation. There are 5 to be exact here. The first one is blind estimation of a random variable. The second one is estimation of random variable given an event. The third one is estimation of random variable given one other random variable. The fourth one is linear estimation of a random variable given a random vector. And the last one here is linear prediction of one component of a random variable given other components of the random variable. So for this video presentation of ours, we are going to be explaining about the second one, estimation of a random variable given an event. So I'm going to pass the next part to my next teammate.
Okay, I will be explaining about how we get the formula. Before that, we ask ourselves this question: what is the minimum estimated error of random variable x with given a? In general, the estimation of x is the function of y, with a equal to y, and then from that, we receive x F.A is equal to gy. Moving on to estimated error of x is equal to x minus xa, and then substitute it and receive x minus gy. The mean square error given with a is this equation right here, the highlighted one. And this whole process is also known as the blind estimation. And from that, we receive the quadratic function right here. And then we have to find the derivation of that function, which is later we receive minus 2ex plus 2a equals to 0, and then from that we got a equal to ex. And then from this whole process we can conclude that xa is equal to estimation of x with given a.
Okay, so now I will cover about the application of the RV estimation. There is a few applications where the RV estimation is used. The first one is in medical industry. In medical industry, RV estimation is used to estimate the prevalence of the disease that the patient has. We can also use RV estimation to count the death count in a certain condition. For example, like from a disaster or from a plague or and we can estimate the patient's chance of survival from a certain disease. In automotive industry, we can use RV estimation to estimate the damage on a certain vehicle, and we can also estimate the depreciation of a certain machine. In general industry, say if we want to estimate the average production that we produce, we can use RV estimation. And we can also use RV estimation to estimate the required temperature if you want to produce a product that require an oven or a refrigerator or anything like that. So next.
So we have an example for this topic. The duration 10 minutes of a phone call is an exponential random variable with the expected value of 3 minutes. If we observe that a call has already lasted for 2 minutes, what is the minimum mean square error estimate of the call duration? Okay, so here's the solution. Okay, the PDF of t has been solved in the example 3.34, which is the function ft of t is equal to 1 over 3 times the exponential of minus 3 divided by 3 for if the time is equals and greater to 0 and 0 if it's less than it. But in this question, the call is still in progress after 2 minutes. So we have which is the element of A, and t is greater than 2 minutes. Therefore, the minimum mean square error estimate of t can be written with this formula, which is t of A is the estimate of t, and t is greater than 2 minutes. And by plugging this value, we can have the conditional PDF of this problem, which is 1 over 3 times the exponential power to this thing, and this is for the time if it's equals and greater to 2 minutes. Okay, so previously we have obtained this TA formula, and it can be written in the integral form as the integral from 2 to infinity of t times the function dt, or this also can be written as the integral of 2 into infinity t times minus t minus 2 divided by 3 dt. Okay, so by applying the this partial integral formula, this part, which is the t, can be the u, and this part is the dv. By applying the partial integration formula, we can obtain t minus 2, 3, 2 to infinity times the integral minus 2 bagi 3 times 1 dt. Okay, so this part stays the same, and we can integral the second part, so we can write as minus t plus we can write it like okay. So by inserting this value of 2 and infinity to this function, we can obtain the end result. And don't forget that in exponential, e times infinity equals to 0 and e times 0 equals to 1. So from here, wait, this part is 0, since if we input infinity into the exponential, exponential powered by infinity is 0, so it's 0, and it's minus, and it's minus 2, because uh, if we place the 2 in the exponential will be 1, and this part is minus 2, so it's 0 minus 0 2, and then plus in the second part it's almost the same. If we place infinity, it will become 0, so it's 0 and minus. If we put 2 here, this part becomes 0, and it becomes 1, and it's only minus 3, so minus 3. So the end result will be 5 minutes. So here's the solution.